Hello, Math3430. This is a lecture on Python function arguments, which is a little bit complicated, and it involves some stuff that doesn't really come up till later, so I'm a little bit disappointed in the result. But here we go. What kind of arguments can you have to a function? Well, the thing we're used to is what's called positional arguments in Python, like this, f of x, y, and let's just print x and y. And then let's go on here and run that through, and then we will plug in a couple of values, 1, 2, and lo and behold it prints 1, 2. Now how did it do that? Well, first formal argument lines up with the first actual argument. Second formal parameter lines up with the second argument. You just the position of the variables determines which values they get when you make the function call. That's usually the way it's done in mathematical notation, so we're pretty used to it. In Python, you can have something else called a keyword argument, and you're staring at one right now on the screen. Here it is. We have this Python function run file. This string is the file to run, and that's evidently a positional argument. And then we have this keyword argument where we set the variable wdir, I'm sure it's working directory, to something else. So it's often used to give values to optional information you can include that has a default or doesn't matter if you don't include it. So for example, if we look at the help on the print function, which we've used a lot, well, it says you can print values ... so you can print a bunch of values, put in a bunch of values to be printed. It also has 4 optional keyword arguments: the file, the separator between elements, things on the line, the thing at the end of the line, and so on. So these are things you can include if you have to, but you can leave them out if you don't. So just like here, the default value for the separator is a space, and we can change that if we want. If we go over here and do separator equal, it doesn't matter if there's a space, comma space, then if we run this function, let's run this file through, f1, 2, and now it prints out, but we've got a comma after the 1. So that's the idea. Optional parameters is they're frequently used for. Another reason for using them is to use a name that makes it obvious so the user doesn't forget what he's doing in that particular variable. So let's talk about that, keyword parameters with default values, or those are called default arguments often. So let's define a function g. We got 2 positional parameters, and let's say a is 100 and b is 200. Okay, so those are the default values right there at 100 and 200. And then let's just do print x, y, and then on the next line let's print a, b. Okay, so let's run that through. So if we do g of 1, 2, a equals 10, b equals 20, it doesn't matter, the order doesn't matter really. We could do b equals 20 and a equals 10. Since you're not counting on the position of the argument to determine what argument it is, you don't need to have the order in any particular order. And the result is that you get x and y printed in the first line and a and b printed in the second line, and they're 10 and 20 instead of their default values. But if I leave one of them out, b equals 20, then everything's fine except that that variable gets its default value. Okay, so everything's good. That's a nice feature. And the only thing you have to watch out for when you define the function is that the default parameters have to come after the positional parameters. If you tried something like define h x a equals 100 y, it doesn't matter what it does, pass, then non-default argument follows default argument. So you can't do that as far as in the definition goes. So let's do a little list over here, which we're going to do the way we can do this. Let's do, if you're defining a function, you have to have the positional parameters, or let's call them arguments. That's more or less of synonyms in my vocabulary. And then you have the default arguments. So that's a valid way to define a function. Now I have to warn you about one gotcha using default parameters, which comes up if you try to use a value of a mutable object as the default. If you try and use a mutable object as the default. So an example is, here's a simple example of the problem. Let's define a function. Let's call it SI for stick in, and we're going to have an element and a list specified by a positional parameter, keyword parameter, and I'm going to default it to the empty list. And you could say, well, okay, all I have to do is say L.insert place 0x, and that would do it as far as the list is concerned, because L is the reference to the list. But for convenience, let's return L. Looks very simple. Okay, now let's see what happens. So let's start with the list A, make it 10, 20, 30, and let's call stick it in 1A. So that's the new list, and notice that A has become that list too. As I said, the name of the list there is a reference to the memory storing the list, so you can change it. However, suppose I try putting in, leaving the parameter out, and so L is going to default to the empty list. So if I insert 1 in an empty list, you ought to get a list containing just 1. And that's what I get. So you say, okay, now if I take 2 and insert it in an empty list, I got to get a list containing just 2. Oops, that went wrong. And if you keep using it, it just keeps going. Okay, so what was the reason for that? Well, the reason is when you execute this definition statement, that's an executable statement, it evaluates the default here. It assigns a definite value to it. So it creates an empty list and assigns that list to L. And that's what L defaults to thereafter, is that list, just one list. And so we're added 1 to it, but we got the same list when we default this, and so on. So that didn't work the way you expected it to. And the cure would be something like this. Define, let's call SIG for good, X, L equals none. No list specified. And then in the body of the function, the first thing I do is say, if L is none, then let L be an empty list. Now that happened when the function was created, when the function was executed. So that's going to be a different empty list on the different executions. And then we'll do just the rest of the code like we had it. Oops. Come on. Okay, so that's our new function. And if we try that, 1, okay, and as I do 2, get 2, and so on. So that works correctly. So that equals none is a good trick. If there's no, if it's a mutable value, or if you're not sure what to do about the default, then you set it equal to none, and then you can check it inside the program if it's equal to none, and set it to the appropriate thing. Okay, so that's default arguments, and it allows you to have optional arguments. Something that's a little scary, if I show you, is over here, let's say G, which has 2 default arguments. I could do G of A equals 100, X equals 1, B equals 200, Y equals 2. And so suddenly my positional parameters became parameters that you can specify with keyword notation, but don't get too carried away. For example, if you leave this one out, then you're missing a required argument. The default arguments might be optional, but whatever syntax you use, the positional arguments are not optional. Okay, so that's pretty straightforward stuff and very useful. Okay, well, there's another problem you can deal that adds a step of complication to this, which is an arbitrary number of arguments. You don't know ahead of time how many arguments there are going to be. So, for example, in Python there's a function sum, if I believe, and you can do the sum of 3 elements. Oops. I seem to be wrong. Sum. What does sum do? Oh, it's the start value plus an iterable of numbers. Okay, so you need an iterable, which is what I was saying. So, what? So that should have worked. No, I see why it didn't work. You could get the sum of a list or something like that. But suppose I just want to type, let's call it my sum. Suppose I just want to type something like 1, 2, 5, 9, keep going. We don't know how long I'm going to go, but you can certainly sum up those numbers. So how can I do that? All right, well, let's do it over here. So let's call it my sum. And what we need to do is take an arbitrary number of arguments, or a number of arguments that's not known in advance. There's usually a way to do that in a programming language. The way here is the magic is star arg. The star is what's doing the magic. Arg stands for arguments. That's the conventional way of writing it in Python documentation, but it's just any identifier. You can use something else if you wanted to. Okay, so let's just print that to see what happens, and see what arg is. So over here, let's do print. Let's do my sum of 1, 2, 3, 4, 5, 6. And what do you get? You get a tuple containing all those arguments. So all you have to do is iterate over the tuple, and you're done. So you could say, okay, now what I'm going to do is I'm going to say, well, there's a number of ways I could sum a tuple, but let's not get fancy. Let's just do it the easy way. So let's do start sum at 0, and then for in args, this had better work, or I'll be upset. S equals S plus N. Okay, now let's do return S. Return S. Okay, that ought to do it. Okay, it's not a syntax error. So let's do my sum of 1, 2, 3. Args is not defined. Star, yes, okay, I should have said args up here. Sorry about these minor errors. Unless somebody is a film editor who wants to volunteer to help me out, you're going to have to put up with them. Okay, so let's do my sum again. 1, 2, 3, 4. 10. Let's see. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. So that's correct. Okay, so that allows us to take an unknown number of arguments. We just have to realize it's a tuple, and we're going to have to manipulate things with that tuple. Okay, so I don't think there's any point in making that any fancier. I think it made the point. you can have positional arguments and default arguments and arbitrary number of arguments in the same function. Say, define h. So let's first do x and y positional arguments, then star args, then a couple of default arguments. And as usual, I'll just print it out so we can see what we're getting in the function to have to work with. So print x, y. Print args, but that's going to be a tuple. And then print a and b. Okay. So if I do h of 1, 2, what happens? So there aren't any extra arguments, and there aren't any, I didn't specify any keyword arguments. Well, of course, the a and b are going to take their default value. What happens to the args? And the answer is probably predictable. You get an empty tuple. Right? So you might have to check for that if you're processing a function like this. And so if we do h of 1, 2, 7, 8, 9, a equals 1,000, then 1 and 2 go to x and y, and then 7, 8, and 9 are arbitrary, what do I want to say? There isn't really a good name for this. They're star args, things that weren't, we didn't know how many of them we were going to have. So they came right after the positional arguments. So we can change our Python function definition pattern to, let's see, what do I want to do? Where's it? So def some function. So you're going to have the positional parameters, args. Then you're going to have possibly star args. And then you're going to have the default parameters. Okay. Well, there's a trick with, you might say, what about an arbitrary number of keyword parameters? Okay, well, you can do that. Keyword parameters that aren't specified in the definition of the function. What you need to do is add star KWRs, keyword arguments. Against KWRs is the convention, but it could be any name. Okay, and that will give you, well, let's see what it'll give you. Let's define a function like that and see what we have. Define f of x, y, star args, a equals 100, b equals 200, and then star keyword args. Okay, and again, let's just print things out. So print x, y, print args, print AB, and then let's do print keyword args. So let's do a function call here. Invalid, typo. invalid syntax. Here we go. So f of 1, 2, 3, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, A equals 1,000, forget B, and let's do K equals 100, J equals 300. So K and J are in the format of keyword arguments, but you haven't seen them before. Okay, so let's see what happens when we execute this. Okay, so what we got back was 1, 2 got their values. We got packed all of the additional positional parameters to the args tuple. We have the value of A, and B takes its default value. And these things get packed in a dictionary where the name of the keyword argument, notice this is a string, is the keys, those strings, and then the values on the other side of the equal sign are the value in the dictionary. And of course, if you leave off if you don't have any additional keyword arguments like that, then you get an empty dictionary, which is a perfectly good thing. Okay, now how do you process that keyword dictionary inside the function? And the answer is, well, you might think I ought to be able to easily say, okay, I got past K equals 100 and J equals 300, so now I want to have two variables that are called K and J that are 100 and 300, and the answer is, sorry, there isn't really a good way of doing that. There sort of is in a more general context, and this star keyword arguments is actually probably exists for a more general context than we're talking about now. So I can't give you any great insight into that. You know, if you wanted to do the sum of the keyword arguments, you could do, well, let's see, if keyword args, well, let's see, how do you say the empty dictionary? Keyword args, how about len keyword args equals 0, then return sum, or sum equals 0, sum of 0 things is 0, and then on the other hand, else return else sum equals keyword args with key j plus keyword args. Okay. Okay, and then let's return sum, I guess. Or print sum, I guess. Print sum. Invalid syntax, else should have a : on it. It starts a block. Missing parentheses on print, yes. Wrong version of the programming language. Okay, so H1, 2, got to have those. And then let's just say K equals 100 and J equals 300. Got an unexpected keyword argument, K. Oh, it's called F. I'm getting a little groggy after trying to figure this stuff out. Keyword arg is not defined. That's because it's keyword args. Okay, sum is 400. So really, the use case is not so obvious there at the moment. So I guess I don't think there's too much more I can say at this time about that. Maybe somewhat later we'll get a more clear use about what to do with this. But at least you can get that stuff in theory. You gotta have to know what keys, or at least what kind of keys, you're expecting in order to do it. Okay, well, there's one other advanced topic I'll put in here, which is making the arguments have to be positional and have to be keyword. So let's define a function g of, let's call it xy, and then in the entry in this slot I put in a slash, and then I put in, let's say, zw, and a equals 31. Okay, so let's just do the usual thing. Print x, y, print zw, and then print a. Okay, so this is all straightforward except what the slash does, right? Okay, what does the slash do? Well, I can do g of 1, 2, 3, 4, and ignore the default argument, and get x equals 1, y equals 2, z equals 3, 4. But I can also do g of 1, 2, w equals 5, and z equals 10. Use the keyword style for those, and that works. But if I try to do x equals 1, y equals 2, z equals 3, z equals 3, z equals 3, and then z w equals 10. Got a positional only arguments passed as keyword arguments x, y. So everything that comes before the slash really has to be given as a positional argument. You can't use the alternate keyword syntax. Things after the slash can be either positional, like ZW was the first time we called it, or it can be keyword. but everything before the slash has to be positional. And there's a similar one to force it to be keyword. So let's take this function and modify it a little bit. Let's start, let's let z be itself, and then let's do star in a slot by itself. Okay, and then let's run it. Okay, so what goes wrong is if I try to do 1, 2, z equals 3, 4, so w equals 4, then it objects because everything after the star has to be a keyword argument, and so the things w couldn't be specified as a positional argument. In order to make that work, I would have to go 3w equals 4. Okay, so you can force everything by there without giving, I'm being vague. You know, everything after the star has to be a keyword argument. You have to use keyword syntax. Okay, and this is the only way I know of specifying that w is a keyword argument, but I haven't given it a default value. And of course, so if you try not giving it a value, g, x, y, 3, a equals 50, 60, then what happens is, of course, it says name x is not defined. Where? Oh, let's run this. Okay, so g of 1, 2, that's x and y. 3 for z, ignore w, and then do a equals 100. And missing one required keyword only argument w. So you have to assign something to w, but we haven't said what. Okay, so the star and the slash are recent additions to the language, and I'm not, so it's kind of advanced, but they're very useful now that we've got them. Okay, let me do one other topic as a short topic here, because it will save making a short video, which is the star and double star have another use, or the same use, which is as unpacking operators. So, for example, it doesn't work everywhere, but it works in function arguments. So suppose I make a function that takes 3 variables, x, y, and z, and of course I'm going to, you know what I'm going to do with those, doesn't much matter, x, y, z. Okay, so I run that, and then over here I've got a list of 3 numbers. And I would like to plug those numbers in for x, y, and z. But it's in a list. How do I can't just say, if I try saying f of a, then I get missing x and y. X is the list A, but I'm missing x and y. So somehow I've got to take it out of a list and put it into the variables x, y, and z, and the answer is star A. So the preceding star tells me to unpack it into a tuple essentially and use tuple assignment. But you know, just take the round brackets off and work it, give me the answer. And I think it works with any iterable. If you do f of star range 4, 3, that works. And range is not a list. It's something more complicated, but that gives me exactly what I needed. So that unpacks any iterable into the positional parameters. And you can do something with keywords if you have a function. Let's see. Do I have one that had 2 parameters? How about h is good. Suppose I take define a dictionary, which is let's say A 30, 40, and B 50. That's a dictionary. A is not defined. Those should have been strings. Instead, it's trying to look up a variable called A, which isn't assigned to anything. So I need to make these strings B B is a string. Okay, so there's a nice dictionary. Has 2 entries in it. So suppose now I take my function h up here. Here it was. So it's got 2 keyword parameters, a and b, which it needs assigned. So what happens if I do h of 1, 2, and let's see if this works. I'm not sure it will. Something for args. It doesn't. For args, let's do star star d. Okay, so it unpacked the dictionary into a equals 40 and b equals 50 and put them in there. So they got into keyword arguments. So you might say, well, oh wait, it's just I solved my problem of what to do with keyword args. I just star it. No, it only works in certain contexts, and that's not one of them. So another context in which we've seen that is if you have 2 dictionaries, D, E equals what? C, X is fine. Assign has value 100, and you want to merge the 2 dictionaries. Then the syntax is star star D star star E enclosed in dictionary brackets, and star star E. I'm getting groggy. E. Okay, so that put the 2 dictionaries together. Basically just gave you all the pairs with the colon in between, just gave you all of those in a list, except that what happens if my dictionary A, B, C, D, E, let's use R, that's not used yet. Suppose that's A equals 500. 5,000 is good. So colon 5,000, and it should be a string. 5,000. 1, 2, 1, 2, 3. Okay, now, so that's a dictionary with one entry. And remember, D had A at 40. So what happens if I do star star D star star E? Well, there's a conflict of keys. A is given two values, and the answer is the one on the R is what I wanted, of course, not E. Definitely time to bring this to a close. R. Okay, so it overrode the previous value of A. So you should think of these happening first and these happening later. So doing it later will override what happened doing it first. So if you have a dictionary, a big dictionary and a little dictionary of changes, doing it this way, it'll make the changes without having to, it's a short way of doing the changes, a short way of merging the dictionaries. Okay, well, that's all for this video, and I'll see you soon, I'm sure. Signing off.